10-4, Solving Radical Equations. A radical equation is an equation that has a variable and a radicand. For example, we have the square root of x minus 5 equals 3, and this would be considered a radical equation. The first thing that we're going to do with these radical equations is solve by isolating the radical. If we have a problem that looks like this, the square root of x plus 7 equals 16, we're first going to solve it like we do any normal algebra problem. We're going to move the 7 over, subtract 7, so we'll get the square root of x equals 9, and then to undo that square root, we will square both sides, so we will get square root of x squared equals 9 squared, so x will be 81 in this problem. What if I gave you the square root of x minus 5 equals negative 2? The first thing you would do would be your simple algebra, add 5 to both sides. So the square root of x equals 3. Then we'll square both sides to undo that square root. We will end up getting x equals 9. This is just like any other algebra problem we've done before. Now we just have our radical. Let's do a couple more examples. This one, I would like you to bring the answer of this to class. And this will be how I tell if you watch this video. So answer, 3 minus the square root of t equals negative 2. And we will discuss this one in class on Monday. Next thing we're going to do is use a radical equation to solve a word problem. So, the time t it takes for the pendulum of a clock to swing fully is approximately t equals 2 the square root of L divided by 3.3, where L is the length of the pendulum in feet. If a full swing takes 3 seconds, what is the length of the pendulum? Now we are given an equation in this, and we are also given what our t is meant to equal. So we will plug that in and solve the equation from there. So we have t equals 2 square root of L over 3.3, and then we'll plug in 3 for t, and we'll get 3 equals 2 square root of L plus 3.3, or divided by 3.3, excuse me. So then, to undo our multiplication, we will divide both sides by 2 and get 1.5 equals the square root of L divided by 3.3. Then we will square both sides in order to undo our square root. And then we've got 2.25 equals L over 3.3. And then we'll multiply, and we'll get 7.425. So the pendulum is about 7.4 feet long. How long would the pendulum be if each swing only took 1 second? So we'll plug 1 in and do the same thing as before. In this case, if the swing only takes 1 second, the pendulum is only 0.82 feet long. Next, we're going to look at solving when we have radicals on both sides of our equation. For example, if we have the square root of 5t minus 11 equals the square root of t plus 5, to solve this, we need to square both sides to undo those square roots. Once we do that, we will get an equation that we have seen before, and will be extremely easy for us to use our algebra skills to solve. So we will get 5t minus 11 equals t plus 5. Now you can either move the 5 over first or move the t over first. Personally, I would move the t over first because then we'll make sure we have a positive t value. So then we'll get 4t minus 11 equals 5. Add 11, so 4t equals 16. And then t will equal 4. What if I gave you the square root of 7x minus 4 equals the square root of 5x plus 10? We're going to do the same thing and square both sides. So then we will get 7x minus 4 equals 5x plus 10. Use our algebra skills and do those steps. So we'll subtract 5x, and then we will add 4 to the other side, divide by 2, and we will get x equals 7. Now this next thing that we're going to talk about, we need to look at these equations that we have here. So our original equation would be x equals 3. Now if we square x, we would get 9. But when you have 9 equals x squared, technically x equals plus or minus 3. So we have manipulated our x, and now it is not the same as our original equation. So we're going to look at when this happens, and we call this an extraneous solution. So an extraneous solution is an apparent solution that does not satisfy the original equation. So we will always want to sub back in to check our answer and make sure that it's not an extraneous solution. So now we're going to look at identifying these extraneous solutions. So if we are given n equals the square root of n plus 12, we're going to figure out if we get any extraneous solutions when we solve this. So we're going to go through and solve it like normal. So we're going to square both sides to get that square root to go away. So we will get n squared equals n plus 12. And now we will go about solving it. So to do that, we're going to have to subtract n and 12 from the other side and get it equal to 0 so we can factor. So we'll have n squared minus n minus 12 equals 0, and then we'll factor it. So it'll be n plus 3 times n minus 4 equals 0. And from here, we're going to look at those solutions. So we're going to get n minus 3, or n equals 4. Or, excuse me, n equals negative 3, or n equals 4. So now to see if either of these are extraneous, we're going to plug them back into that original equation and check. So 4 equals the square root of 4 plus 12. 4 equals the square root of 16. So that one works out. But when we plug negative 3 in, it does not work out. So that means it's an extraneous solution. What if I give you negative y equals the square root of y plus 6? We're going to square both sides. So we're going to get y squared equals y plus 6. So we'll do the same thing. Subtract it from both sides so we can factor it. And then we'll get y minus 3, y plus 2 equals 0. So our solutions will be y equals 3 or y equals negative 2. So now we'll plug those back in to see if they're extraneous or not. Negative 3 equals the square root of 3 plus 6. Now I see where this one's going. Negative 3 equals the square root of 9. Nope, it does not. 2 equals the square root of negative 2 plus 6. This one looks more promising. 2 equals the square root of 4. Yep. So negative 3 is our extraneous solution. And negative 2 is just a normal solution. Alright, so now we're going to look at identifying equations that are going to have no solutions. So if I gave you the square root of 3y plus 8 equals 2, we're of course going to subtract 8 from both sides and then square it. In order to get 3y equals 36, so y will equal 12. Now, we need to plug that 12 back in in order to see if it works out. So it'll be 6 plus 8 equals 2. 14 does not equal 2. So this equation has no solution. No real number solution, I should say. So if I give you 6 minus square root of 2x equals 10, you're going to solve this one and bring your answer to class on Monday. And this is where your lesson is done. So have a great day.